Today in science class, we're taking a look at IXL learning activity G.6. We're going to practice identifying whether objects are accelerating. Well, to do that, let's go back and review what acceleration means. Acceleration is the change in velocity divided by the time it takes for that change to take place. So change in velocity can be defined as two different things. You could be changing velocity by speeding up, or you could be changing velocity by slowing down. Acceleration also has direction, so if you're changing direction, that's the third way in which acceleration is taking place, because the direction that you're traveling is changing, therefore your velocity is changing. A lot of times either you're slowing down or speeding up based on how that change in direction is taking place. So remember these 3 points. Acceleration has direction. If an object speeds up, the acceleration is in the direction that object is moving. And if an object slows down, the acceleration is opposite to the direction the object is traveling. What are the 3 ways to accelerate? Here's what you're going to use to check the scenarios that are given on the IXL activity. Is the object speeding up? Is the object slowing down? Or is the object changing direction? If the answer is yes to any of those questions, then you can identify if it's accelerating. If it's no to any of those questions, then we'd say that that object is moving at a constant velocity and doesn't have a change in velocity which has acceleration. Let's take a look and get started. A canoe is turning to the left to avoid getting stuck in shallow water. Which statement describes the canoe's motion? Canoe is accelerating in this case because, again, we're going to answer 3 questions. Is it speeding up, slowing down, or changing direction? And changing direction can be described like this: turning to the left. If something is changing direction, that means it has acceleration. Therefore, the canoe is accelerating. An asteroid is flying directly toward Mars at a steady speed. Which statement describes the asteroid's motion? If it says it's flying at a steady speed, is it speeding up? No. Is it slowing down? No. It's going directly towards it, therefore is it changing direction? No. We answered no to all 3 of those questions. Then we'd say the asteroid has a constant velocity. An antelope is running faster and faster away from a hungry lion. Which statement describes the antelope's motion? Now here it describes running faster and faster. If you've ever been scared of something and then had to react to that, maybe you can tap into the idea that, well, you're going to do whatever you can in that moment to make sure that you're okay. Well, that fight or flight response is what the antelope is going through, and they're going to run faster and faster and faster and faster than they even think they can run in order to try and survive. Because it's going faster and faster, that means it's speeding up. One of our 3 questions: speeding up, slowing down, changing direction. If the answer is yes to that question, speeding up, then we would say that the antelope is accelerating. A sled is slowing down at the bottom of a snowy hill. Which statement describes the sled's motion? Again, our 3 questions. Is it speeding up? Is it slowing down? Is it changing direction? Right here describes slowing down, so we say it's accelerating, even though that acceleration is in the opposite direction. A boy is lying still in his bed as he sleeps through the night. Which statement describes the boy's motion? This one might be a trick question because you're laying still, you're sitting still. Are you still in motion? Technically, because you're on Earth's surface, you're being a part of the rotation of the Earth, but because there's not a speed up, not a slow down, not a change direction, we're going to say constant velocity with that motion of the Earth. A skydiver is moving downward with decreasing speed as her parachute opens. Which statement describes the skydiver's motion? Imagine you jump out of a plane, and as you're falling to Earth, you get to what's called terminal velocity, where you're not falling any faster. You then pull your ripcord on your parachute, it opens up, and you start to slow down how fast you're falling. 3 questions again. Is it speeding up, slowing down, or changing direction? In this case, it says moving downward with decreasing speed. That would mean that you're slowing down. Stage 2. Which of the following toys are accelerating? Select all that apply. Again, we're going to take our 3 question kind of buffer and apply that to each of these scenarios. Is it speeding up, slowing down, or changing direction? And use that to identify. A toy boat that is moving faster and faster as it plunges down a small waterfall. Faster and faster is our description. A stuffed Tyrannosaurus Rex that is standing motionless on the shelf. A frisbee that is slowing down. Our key words: moving faster and faster, slowing down. Which of the following fruits are accelerating? A pomegranate that is flying upward with decreasing speed after being tossed in the air. As it's flying upward, gravity is pulling back down on it, so it's probably going to slow down at the peak and then speed back up. It's definitely accelerating. A heavy coconut that is speeding up as it falls from a tree toward the ground. And a papaya that is moving straight along a grocery store conveyor belt at a constant speed. If it says it's moving straight at a constant speed, it's not changing direction, speeding up, or slowing down. So just these two. Which of the following boxes are accelerating? A box of tangerines that a man is carrying as he turns a corner. He's turning a corner, therefore he's changing direction. A box of cereal that is moving along straight conveyor belt at a steady speed. We just had that one in the last example, but it's a different description here, so it's still not acceleration. A box of jewelry that a girl is holding still in her lap. If she's holding it still, is it speeding up, slowing down, or changing direction? Box of cereal is moving straight on a conveyor belt at constant speed, so both of those are not acceleration. Which of the following books are accelerating? A comic book that is sliding across a coffee table with decreasing speed. Decreasing speed is our giveaway. A science fiction novel that is speeding up as it travels down a library book drop. A partially finished coloring book that a girl is waving in a circle. All three of those have slowing down, speeding up, changing direction. Which of the following bottles are accelerating? A bottle of formula that is rolling at a constant speed directly away from a baby. A bottle of water that is lodged in a bucket of ice at a cookout. A bottle of detergent that is moving toward the floor with increasing speed after falling off a washing machine. Just this one because it's moving and speeding up as it's falling. This one's sitting still. This one's moving at a constant speed, therefore it's not speeding up, slowing down, or changing direction. Just like that. Take those three questions into consideration when you're thinking about acceleration. Is something speeding up, slowing down, or changing direction? And apply that knowledge to identify if something is accelerating. God's blessings.